proof? Almost
Given?
always. It's always a given, yeah. And sometimes sometimes that doesn't help because you actually need to look at it. And I like to mark up the drawing as we go. So like AB is congruent to CD. Okay, those two segments are congruent, and that is given. Now the next line, we've talked about this idea of like what's the same, what's different between line to line, right? So like what's the same, what's different
Yeah.
about them? What do you see?
The it's no longer the symbol for congruency, it's equals, and also it's not referring to
Right. So
the
it's kind of like the whole
yeah.
like angles, congruent angles have the same measure, congruent. It's like there's gonna be something that says like congruent lines have the same length, something like that.
Yeah.
But please click that drop down.
Def of congruent segments. Is that
There it is. Possibly, yes,
there?
that would be a good. That's good. Okay. So now the next line is unrelated to these. It's saying AC is equal to AB plus BC. So the whole is equal to the part plus the part. And then CE, the whole, equals the part plus the part. So that is the segment addition postulate, maybe something like that.
Yeah.
And the key word there is addition. Like they're adding, so probably the word adding is going to appear in the region. Now on your tests, is it drop downs like this or is it written?
I think it's like yeah, like drop downs.
Okay. I'm asking just so I know how to best help you. Like that's the only motivation. Because if it's written, more words the better to kind of emphasize what you're trying to do. Drop down, you don't get any grace if you know miss miss grabbing it. So okay, so CE is now equal to AB plus BC. And you're like, where did that come from? Like where does that even come from? Well, um, you kind of you gotta decide, well, is it from the previous line or is something else going on? Well, CE was DD plus DE, but now it's AB plus BC. Well, how can that be? Well, it's because of this in the previous line. It's because of the fact that CD, let me color code it here. CD is really AB and DE is really BC. And that's where those come from in the next line. They're replacing it here. So to me, that's like substitution. Is that a possibility?
Yeah, substitution property.
Okay. All right. And then for the next one, it's kind of the same deal. It's like, where does this even come from? Well, CE is equal to AB plus BC. AC is equal to AB plus BC. So they must equal each other. It's like if AC equals this and AB equals this, when you have like something leads to something leads to something, that is the transitive property. So it's like AC is really AB plus BC. AB plus BC is really CE. That is transitive. One leads to the next, leads to the next. Is that okay?
Yeah.
And then the last one here is it's kind of the opposite of the first two lines. It's like going backwards. It's like, wait, they have the same length, so they must be congruent. So it's probably something like segments with the same length are congruent. Something like that. Or could be a converse situation. I don't know if you talked about that in class, but converse is when you're going backwards from the definition.
We did get to that, but not it wasn't really a fleshed out thing. the concept of like the converse and um the other four things, other three things. There were
Yeah. Inverse, converse, contrapositive, stuff like that,
yeah.
maybe. Okay. All right. Let's see. That's it for that one. That's any thoughts on that?
No.
We probably should have started with this one that I see next in the email here. This is like your warm up beginner proof because there's no geometry. It's just like stuff you already know, but maybe you don't know the words. And good. I like that you're like, hey, I can at least do the given. Like, you know, gotta at least get the easy stuff, right? And then
Yeah.
I want you to try, I want you to try this. Like, and you don't have to do them all right, but like, we can't just be Matthew working through these. You got to be, what do you see that's going from like line one to line two? This one's much easier because every line leads to the next. So
Yeah.
either like what I'd like you to do is either tell me or go through all of them and then tell me or some combination thereof, like we're um,
Would that be the distributive property?
the first one is definitely distributive, yes. Okay. And then you just look like, well, what is the math operation that you're doing to go from line two to line three?
Um, moving the two to the other side. That would be no. Substitution.
So sometimes it's like you gotta maybe just write it out and be like, all right, what do I do next to solve this? Well, you do this. And I don't want to say because that's the answer. What am I
Oh,
doing?
subtraction,
Yes. So it's the subtraction property of equality.
and then division.
Yes, division property of equality. So actually the next few are of this type, and they're literally just the math operations that you're doing. Like whatever the math thing that you're doing is, that is the reason. And are you checking these as we go, or just they're just submitting it like at the end? Like what is, or you've only got
Yeah,
one
just
left?
submitting it at the end.
Okay, yeah, all right. Um, I'm just telling a student to check something and they like they lost all their checks. It was really bad. So I don't. Okay. The first one is given here. I'll do the hard one. Could you try the rest, please, and let me know what you come up with on this?
Sure. Okay, so I got subtraction property and then subtraction property again, and then division.
So I disagree with from 2 to 3 because you're moving this minus 18 to the right. How do you undo subtraction?
Uh, oh, I understand now.
Should be the addition property, and then I think I don't remember what you said, but would be division.
Yeah, yeah.
All right. So the next one is similar. I think it'd be good for you to again try this. It's just the math operation. Now, what you could do to maybe make this easier is to not like focus so much as it here, like maybe come over to the side or another um off to the side here and like work it out on your own, like almost covering up what's over here. And like, all right, well, what am I going to do next? And the first thing you're going to do is take this 4 and multiply the 5n and the 7, take this 3 and multiply the 4n and the minus 9. And you just sort of say, okay, I'm gonna work this out where I uh then go and say, well, what did I do? What did I do to get to that line? Oh, whatever that is. Because and not focus so much on like the statements, like do your own work and then compare it to the statements to see what you would do next. That's just a suggestion here, but I'll like you to give this a try on your own and let me know the steps whenever you have them.
All right. Okay, for step two, I have distributive property. For three,
Okay,
I
I
have
agree.
like simplify.
Yeah, I would agree. Combine like terms, something like that. Simplify probably. Good.
Four, I have subtraction,
Okay, agreed.
and then subtraction again.
Yes. Yeah, two in a
Okay,
row. And then
and then division.
you got it. Yeah. Are these all in the drop downs? Like we're not missing some because they're
Yeah, it's they're all there.
oh good. Okay. So you'll actually like these. These are called algebraic proofs. I think if there's a scale, like which do you prefer? These are preferred because they they're more intuitive. You're used to like almost saying the steps out loud because you've been solving equations for a while now.
Yeah.
Any questions, thoughts on that before we move on?
No.
Okay. Next one I have here is 15. I'm just kind of looking ahead here. I mean, you've sent over, we got like one more prime after this. If you want us to work on some other stuff, definitely might want to start thinking about sending that over. We'll definitely not need the whole time to do these two problems here. Okay. Excuse me. Uh, given, it's always given. M is the midpoint of AB. That means that A to M is congruent to M to B. All right. And that's kind of where you see down here. You can't write that yet. That's just what it means. Like just because something's a midpoint, like you have to then sort of like then say that that they're congruent. B is the midpoint of MD. Okay, and that leads to this one here. Okay, so the givens almost always lead to stuff later in the proof. So the fact that it's the midpoint doesn't mean that they're congruent. You write that they're congruent, and the reason they're congruent is the definition of a midpoint.
Yeah.
Okay. The next thing here is we've seen this a few times to go from 3 to 4 was congruent. Now it's just the segment. I don't remember what we said in that one. You gave me some different wording for it. It's the fact that they're congruent means they're the same length.
Yeah. Uh, definition of congruent segments, I
Okay.
think.
That sounds good to me. Right. So then from 4 to 5, sometimes again, like they're unrelated. So MD is M, sorry, M to D is MB plus BD. Basically, they're saying like the part or the whole is equal to the part plus the part.
Is that a segment addition postulate? Is
Yes.
that okay?
And you got to be careful not to just say, oh, well, it must be the same one for the next one must be the same one. It might be, but you got to be careful here. So it's kind of like the last one. It's got really similarities except for this piece right here. Instead of BD, it's using MB. Well, where did that come from? Well, it came from the previous line here. That instead of BD, you can put MB, and that's a substitution. All right, so then from 6 to 7, we're adding them up. Like to me, it's just adding these together.
Simplified.
Maybe simplify. Yeah, I don't know. That sounds okay to me.
Yeah.
Okay. Um, Thoughts on that before we move on?
No.
Okay. All right. I'd like you to try as much as you can on this one. Um, it's not that much than what we've been doing. Like there's like nothing, there's not a new step in here. It's just it's give you a chance to see where you're at as far as like can you get closer to being able to do these completely on your own. I think you can. I think you get it all right. So just take a couple minutes here, and either ask some questions or let me know what you see. Maybe the only one that's new is number two. That maybe not new. Maybe you saw that in class, but we can
Yeah.
talk about that if needed.
Okay, so I have um first of all given, yeah, and then
Good,
reflexive property
good,
of
good, very good.
equality,
Yep. Okay.
and then I think the next one is segment addition postulate. I think.
AL plus LS equals. So, um, what this one is, it really comes from number one. You're adding, you're adding to both sides LS. It's like fairness, if you get LS, then I get LS, whatever that is. I'm not sure what's an option in the drop down. It isn't segment addition because it's not like AL plus LS equals AS. It's not part plus part equals whole. It's yeah, it's something else here. What are some of the options in the drop down that
Is transitive property, segment addition, reflexive and addition property.
I guess I would go addition. So you're adding to both sides of the same thing. You might check with your teacher on that. Say, I'm a little unsure how to proceed on something like this.
Okay. And the next one I thought was also segment addition postulate. Um,
So this one, notice that these are the same, but these are different. Yeah, and I'm not saying you're wrong, but like, well, that's one things to look for. So SK plus LS, SK plus LS, is that AS?
yes, or that's
So, so,
equivalent.
they didn't do a great job here because it's like they really should have put LK here, but since LK is see SK plus SL is LK,
Yeah,
um, they should have had that, and then LK is uh where am I? Oh no, I'm sorry. I'm sorry, Sasha. I'm totally wrong. So everything I just said is completely wrong. You're right. It is segment. They're saying AL plus LS is AS, which is the segment addition postulate. I'm looking ahead to something else. Yes. And then what did you say for the next one?
uh, transitive property.
Let's see here. So if AL AL is really SK and AS, I'm trying to prove that. So I'm looking at like what's the same, what's different. To me, it looks like they substituted. See, this SK plus LS is the same as AL plus LS. That's where I think that that's how they got the left side. But it's like, how did they do the right? How did they get AS is LK? Oh, SK plus LS. Oh, that's another segment addition postulate. SK plus LS. Yeah, sorry, that is another segment addition postulate. It's its own independent line. So sometimes you get caught up in like trying to figure out like where did it come from? It's just its own line. But then that raises the question of why they didn't just put them both in the same line.
Yeah, that is kind of strange.
So like for example, See how they did that here? They're both segment addition postulate. Like these are probably written by different people. Um, so having said all that, now it's like because these are the same, AL plus LS is the same as SK plus LS from line 3. That means AS plus LK is the same. That is transitive for sure.
Yeah, I always find the ones where it's just the letters to be really hard because it's like because numbers is just easier because that's how it it should be done. There shouldn't
Right.
be letters involved. It's too complicated.
I agree. Uh I definitely agree with that. One of the things I think is also challenging here is that you're given all the statements, which I know maybe seems better at first, but usually you build these things organically, so you kind of specify the order. And it's kind of like if you ever had an art class where they say, you're going to draw this, the vase with the flowers and the backdrop, like you get to kind of do your own interpretation of it. And like here, you're forced into this interpretation of the proof. And proofs are a little bit more um, flexible. You don't have to, they're not rigid like other parts of math. You can do them a variety of ways.
Yeah.
All right, so that takes care of everything you sent over. I can, of course, try to find some more. Do you have something else that you would like to work on?
Uh, no, do you have any more things that are similar to this?
Yeah, I can find some. Um, all right, let me look here, see if I can come up with something. Do you do anything on delta math? Do you ever have assignments
Uh,
there? Heard of that before?
not not yet.
Okay, because delta math has a lot of problems like this that um, fill two-column proof. Unfortunately, most of these are going to be like where they give you a mixture of both. Do you know your teacher's style? Like, what do you think? Do you think they'll be like this on the test or quiz? Do you think he or she will mix them up?
Probably mix them up.
Okay, so here let's try a basic one just to see where you're at. If you're okay with this. So the idea here is it's an algebraic proof, but they're giving you some of the reasons, but not all the statements. You're used to getting all the statements, but no reasons. So maybe you can give this a try here, filling these in and letting me know what
All right. Okay, so on the right hand side, the two is addition.
Addition, property. That's another thing. Check with your teacher. Some are like, we grade on spelling, we want complete, clauses, periods, whatever they want. Make sure you know what they want so that you're not surprised when you get your grade back. You're like, oh, I didn't know I had to spell things correctly. All right, how about number 3 over here?
2x equals 20,
Good.
and then x equals 10.
Yeah, and what's interesting is you're kind of putting the result of each line. You're not showing the steps. And you are, but you're not showing, like, it's almost like there's an intermediate step over here where you're subtracting, 3x from both sides, and you're putting the net result into that line there.
Yeah,
Does that make sense?
yeah.
All right. Any thoughts on that before we move to another question?
No.
Okay. So this is the ones you mentioned. This is a much more basic one than the ones we've been doing, but it's kind of more like the style you were seeing here. So just give it your best. It's not super complicated, only 4 steps. Um, give this a try, please, and see what you come up with. How are you doing on this one?
It's like I know um I'm having trouble like remembering what is like how I should put the 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 properties in, like how
So
how do I say?
yeah, don't get caught up on the words. Like I want you to be more descriptive than less descriptive. So like for this first one
Okay.
here, AB plus BC equals AC. Like even if you just said, hey Matthew, it's part plus part equals whole, that's better. That's better than nothing. That's not what they want, but that's better than nothing.
Okay.
Because then you say like, oh yeah, it's a segment addition postulate, or you'll see that in the drop down. All right. And then you look at the next one, you're like, AB plus AB equal to AB plus B. So you're like, oh wait, maybe they're putting in for AC, AB plus AB, right? They're just substituting
Yeah.
that, and maybe it's just substituting, something like that. And then it's like, well, okay, AB is there, BC is there, but no ABs. Maybe they just subtracted them. Something like that would help. Like, even if you're not, excuse me, 100% sure, you can do that. Now, at the end of the notes here, we are out of time here, but what I'm going to do is put this one in the notes, and then the solution to it is going to be below it in case you want to work on another one. If you're just, can't sleep at night and you're like, oh, you got to get another proof in before I go to bed. All right. Anyway, if you do want to practice problem, that is there for you. So, all right, go ahead and